Hello, welcome to Study with Sri. In the previous video, we learned the laws of exponents and I gave you 2 questions to try on your own. So in today's video, we will first solve those questions, then we will go through a full set of exam style exponential equations step by step. So these questions are extremely important for your fundamental understanding and to move on to the more complex questions. So in the last session, I have given these 2 examples. So let's see. These examples are very simple. So there are 2 ideas that we have to think about in this question. The first one, 1 over 8, if you expand it, it's 1 over 8 to the power 2, which is 64. Divided, 1 to the 4 is 1. 4 to the 4 is 256. Now, next we have to move on to the fraction idea. In the fractions, when the 2 fractions are divided, we just have to multiply the reciprocal on the second one, so which is 256 over 1. Now, 256 divided by 64, that would be 4. And the second question, 9 to the power 7 times 1 to the power 4 is 1, 3 to the power 4 is 3 to the power 4 as it is. So now what we can do is, this is 9, let's write the 9 in the base of 3. So you can write 9, just look at this very carefully, this is 9. So I can write the 9 as 3 to the power squared, 3 to the power 2, 3 to the 2, to the 7, divided by 3 to the 4. Now expand it, it's power to the power, 2 times 7 is 14, 3 to the 4. Now you can see these 2 exponents are divided. These 2 exponents are divided. So when you are dividing, the base are identical. So simply you can subtract the powers, subtract the exponents. 14 minus 4 is going to be 10. So 3 to the 10 is your answer. So that's very interesting to understand. So now let's try to solve some more questions to get more idea on this. Okay, so now let's see an example. So let's solve the question. 8 to the x is equals to 32. So just see this example clearly. The key idea here is to rewrite both the numbers using the same base. The key idea here is to rewrite both the numbers using the same base. So I'm going to think 8 can be written as 2 to the 3 and 32 can be written 2 to the 5. So we can simply write 8 2 to the 3 to the x, 32 2 to the 5. Now this is power to the power, so 2 to the 3x is equals to 2 to the 5. Now when the bases are the same, we equate the powers. So 3x is equals to 5. So x is equals to 5 by 3. So hope you get this idea. And let's see another question. Let's see 1 over 49x is equals to 7. So here the idea is 1 over 49 to the x. Again, rewrite everything using the same base. 49, you can write 7 to the 2. 49, you can write 7 to the 2. So this gonna be 1 over 7 to the 2 to the power x. Now this can be written 7 to the 2 to the x is 2x, 7 2 to the x, which is power to the power 2 into x 2x. This denominator, if you write it into the reciprocal, it is 7 to the minus 2x. So 7 to the minus 2x is equals to 7 to the 2. Now when the bases are the same, we equate the powers. Minus 2x is equals to 2. So x is equals to minus 1. Okay. So this is a very common exam technique. Rewrite in the same base is everything. Rewriting in the same base is gonna be everything. So now let's look out some more examples and we try to solve those questions to get the enough practice of these kind of questions. So now let's see another example, which is 25 to the x is equals to 1 over 125. In this question, again the idea is we're gonna rewrite both in the same base. So we're gonna write 25 is equals to 5 to the 2, 125, 5 to the 3. Now rewrite 25, you can write 5 to the 2 to the x, 125, which is 1 over 5 to the 3. Since this is denominator, write the reciprocal, which is equals to 5 to the negative 3. So 5 to the power to the x, power to the power. So power to power, 2 times x is 2x is equals to 5 to the minus 3. When the bases are equal, we equate the powers. 2x is equals to minus 3. So x must be minus 3 divided by 2. So when you can't understand, you can rewatch this video. You can rewind the video and you can rewatch it. And if you still have a problem, in the comment section you can write your doubts. So in the next videos, I'm gonna explain those ideas. And let's see another example. 1 over 16 to the x can be written. 1 over 16 to the x is equals to 8. So again the idea is we're gonna write in the same base. So 16 to the x. So I take the 16, I write 16 in 2 to the 4 and 8, 2 to the 3. Now what I'm going to do is I'm gonna equate this, I'm gonna substitute it. 16 I can write 2 to the 4 to the x is equals to 2 to the 3. Now this is, if you even more simplify, 2 to the 4x is equals to 2 to the 3. So bring the denominator to numerator, the reciprocal, so the sign will change. So 2 to the negative 4x is equals to 2 to the 3. When the bases are equal, the power must be equated. So minus 4x is equals to 3, x is equals to minus 3 by 4. Okay? And let's see one more example. Let's increase the difficulty slightly. 2 times 3 to the x. You can write it as 162. Here, the key idea is 2 times 3 to the x. Try to understand or else try to think if you can write 162 as the product of in the base of 2 and 3. Yes, you can write 162. 81 times 2 is 162. You can write 81 in the base of 3. So 3 to the 4 times 2. Now 2 times 3 to the x is equals to 3 to the 4 times 2. You can cancel this 2 and this 2. Here the bases are identical, so you're gonna equate the powers. So x is equals to 4. Now very simple questions. So in these kind of questions, if you systematically try to solve these questions, a very simple logic, and systematically approach these questions, these gonna be really a cakewalk. Let's see one more example. 3 divided 5 to the x, which is equals to 0.12. So now idea is, this is little trickier and little different from the questions that we have tried previously. So what I'm going to do is, I'm going to write 0.12 as a fraction, which is 12 over 100. So this I can write, if I simplify, I divide both the numerator and denominator by 4. So 3 times 4 is 12. 100 divided by 4 is 25. I can write 25 in the base of 5, which is 5 to the 2. So I can write 3 over 5 to the 2. Now let's go to the question. This is 3 divided 5 to the x. 3 divided 5 to the x, which is equals to 3 divided 5 to the 2. Now observe clearly, 3 and 3 cut. If the numerators are identical, the denominator also must be identical. 5 to the x is equals to 5 to the 2, so x must be equals to 2. This is a very interesting question and slightly a different question from the previous examples. Let me increase the complexity little more, and we will try a one step little trickier question from this. Let's say 2 to the 5, 2 into 5 to the x minus 1 is equals to 250. Now see clearly, we're gonna use the same idea that previously we have used. Try whether you can write 250 as the product of from the base of 2 and 5, in the base of 2 and 5. Yes, let's see. 250 you can write 125 times 2. 125, can you write in the base of 5? Yes, exactly. So you can write 5 to the 3 times 2, and that must be equals to 2 times 5 to the x minus 1. Here cancel 2 and 2. Here the bases are identical. We're gonna equate the powers. X to the x minus 1 is equals to 3. X is equals to 4. Clear? So let's try 2 more questions for this videos, and then I will post some more questions in the some more questions in the video in the channel, and you can try those questions, and I will post small shorts explaining those questions to make it very easy. So next, let's see. 5 plus 3 to the x plus 2 is equals to 14. Now the idea is, let me simplify this 3 to the x plus 2. You can write x plus 2. See, when it is 3 times x, 3 times 2, when the base are identical, you can write 3 to the x plus 2. So the reverse of it, we can write the reverse, which is 3 to the x times 3 to the 2. So now you can write, which is 3 to the x times 9. Now let's go to the question. 14, 3 to the x plus 2. 14, you bring this to the other side, minus 5. This one we have expanded, 3 to the x times 9. 14 minus 5 is 9. You can cancel out 9 and 9. So 3 to the x must be equals to 1. Here the important idea is, to get the 1, the exponents will be regardless of the base, whatever the base could be. It could be 1, it could be 1000, it could be 1 crore, doesn't matter. The exponent should be always 0 to make it 1, so x must be equals to 0. It's a quite interesting question. And let's see one more question. Let's try a question where the power is in the decimal form. Let's see. 4 to the 1.5x is equals to 2 to the 16x minus 1. Now the first idea, let's try to, so the systematic idea, we have tried these questions again in this way. The simple trick, try to write everything in the base of 2. You can write 4 as a 2 to the 2, 16 you can write 2 to the 4. And the next idea, this is the left hand side and this is the right hand side. Always when you are doing some workings, when you are learning something, when you are starting the fundamentals, always write and approach those questions systematically. And if you try the questions, if you try a lot of questions, if you try several questions, you can increase your speed. At the beginning, you shouldn't think about the speed, you should be think about the accuracy. But if you are accurate and if you are practicing so many questions, you can increase the speed. So in the exam, the accuracy and the time management are two important things. But I always suggest when you are thinking about the time management, first focus the fundamentals, try to do those and try to understand them very properly and practice a lot of questions so you can increase the speed and gradually you can cope up with the time management. That's the only way. There is no other way for the time management. You can't learn the book and you can't try like different tricks. There is no other trick. Try the questions clearly. Practice gradually and you can increase the speed. The practice makes you perfect. Simple. So now you can see left hand side, I can write 4 2 to the 2 to the 1.5x. This is power to the power. You can multiply 2 times 1.5x is 3x. Right hand side is gonna be 2 times 2 to the 4 to the x minus 1. So now you can write 2 times 2 to the 4x minus 4. Now this would be 2 to the 1 times 2 to the 4x minus 4. When the bases are identical, when you are multiplying, the power can be added. So 2 to the 4x, 1 minus 4 is minus 3, and the left hand side it is 2 to the 3x. When the bases are identical, the power must be equal. So 3x is equals to 4x minus 3. So 3x is equals to 4x minus 3. So if you solve it, you can write x is equals to 3. Is this clear? So I will post some more questions. I'm placing few more questions. Practice those questions, and then I can post a lot of questions as an image in the video description. Try them carefully and post your answers in the comments. In the next video, I will go through your answers and doubts before we officially start the logarithms, and also we can study about the exponential functions, which is for mostly the A-level students to understand them very carefully. And then if you want to study some advanced exponential. So if you are finding this helpful, like the video, subscribe to Study with Sri and share it with your classmates. See you in the next session.